talking about the solar system and how the humanity explored it till now. And then, as Hervé said, I will focus on comets just because I've been working on space mission involving comets, and I think they are, even if very small objects of the solar system, I think they can tell us a lot. So I don't know, I think you have already heard about how the solar system formed. So just to rapidly go through it, and you see that there are molecular clouds in the interstellar medium, and from there will be a gravitational collapse that will allow a star to its life, and around the star the dust and the gas in a protoplanetary nebula will form planets and all the small bodies that we will experience. I think you may have seen this type of images already from ALMA. So the new planetary systems are forming, and so we are not the only one. So this is why there is only one planetary system, but many planetary one solar system and many planetary systems. And let's have a look to the solar system. Here, just to give you an idea of how many objects are already discovered in the solar system. And you see this is in 2010, the 100 largest object that we discovered. Of course, I don't mean that you will see all of them, but just to give you an idea of how many they are. But of course, there are some which are bigger, which were discovered in advance, because they're bigger, maybe closer. So we will go through the main objects, so the planets, and we will go through the 4 rocky planets, and then the 4 gas giants, and then some view on dwarf planets. And then, of course, there are thousands of moons and millions of small bodies, asteroids, comets. So, and then there is also the interplanetary media, which is a very interesting media, actually, because there you have not only material that it's belonging to the solar system, but also an interstellar component, because of course the solar system it's in a galaxy. The galaxy is moving, and it's moving also through the interstellar medium. So a component of the interstellar dust would in any case come into the interplanetary media. Distances. You see here you have just an idea of how the planets and the solar system body are distributed. You see here the scale, it's in astronomical unit, and you see that the main bodies that we know, they are so starting from Mercury, Venus, the Earth, and then Mars, the Earth with the moon, and then there is the asteroid belt, and then Jupiter, Saturn with its moon, and then also Uranus and Neptune. And then here you have the Kuiper belt, where you have it's like a comet reservoir. And then it seems that here it's ended, but in fact there is still a big distance to go, because the image I showed you before, it's just this here, the small here, the planetary region. And then you have the Kuiper belt, but then there is the Oort cloud. The Oort cloud, it's a reservoir, a very big reservoir of cometary nuclei. These are comets that are still in their very primordial state, because they never have been inside the solar system. So they maintain all the the characteristic of when the solar system formed. And in fact, this is why they are very interesting, and now the European Space Agency approved, and it's developing one of the mission, or the next mission, cometary mission after Rosetta, which is Comet Interceptor. I will talk you about, and it will go and study one of these comets that are in the Oort cloud and never came into the solar system before then, when Comet Interceptor will study it. I will tell you about later. Okay, let's see temperatures, because I told you about rocky planet and gaseous planet, but why there is this difference? Of course, the main difference is the distance from the sun, because the distance from the sun imply a different temperature. So a different temperature will modify the type of material that will compose the planets depending on their distance from the sun. So at inside this frost line, you will have quite a high temperature that will not allow for the volatile material to remain attached to the body that formed at these distances. Okay, so this is why Mercury, Venus, the Earth, and Mars are called rocky planets, because the volatile component, because of the temperature they experienced, it's gone. So the other bodies, the gaseous giants, Jupiter, Saturn, Uranus, and Neptune, they will have quite an important component of gases, of volatiles. And this is, as I said, it's mainly because of the temperature that they experience with respect to the distance from the sun. So now let's start from the closest planet, closest to the sun, Mercury, and then we go outside the solar system, and till the edge of the solar system. I'm showing you these Mercury surface images, which was arranged thanks to the observation performed by Mariner 10 NASA mission, and you see that it's quite old. It's of the very beginning of the solar system exploration, but still you have to imagine that Mercury, it's not such even if it's not so far, it's very difficult to be observed, and also the space mission are very difficult to be planned and developed, because there are harsh environment. The sun is so close that the radiation is very, very strong. So it's not so easy to go and observe this type of planet. It's a planet which is it's the only one that doesn't have an atmosphere, and I told you about. I mean, it's so close to the sun that it's very difficult for it to even, it's small, so there is a gravity component, and it's very close to the sun. So it was very difficult for Mercury to maintain the volatile component. And of course, the Mercury is also quite difficult to be observed even from ground, because it's very close to the sun. So, of course, it can be observed only at dawn or dusk, but not easily. You see that Mercury was studied again in much higher resolution and details by MESSENGER. It's another NASA mission that was launched in 2008. And this was the first after the Mariner term mission. So you see that it's not so common that missions are going to study Mercury. And MESSENGER, after 3 flybys of the planet, and then it orbited the planet from 2011 till 2015, and it mapped all the surface, and then after that it makes a maneuver for the orbiting, and then crashing on the planet. This again, it's another image of MESSENGER. It's a color map that tells you something about the composition of Mercury. And here you see that the next mission to Mercury will be Bepi Colombo, which is already on the way, actually, because it was launched in 2018. And the arrival is for, even if already performed some flybys, the arrival at Mercury will be in 2026. So still to go. In 2027, the routine science observations will start. Okay, let's go to the next one, which is Venus. Venus, it's also called, it's normally thought like a planet very similar to Earth, but in fact it's not so similar. In fact, it is very dense, the atmosphere of Venus. The atmosphere, you see the pressure, it's 100 bar. This means that it's very, very difficult to study the surface of this planet, because only radar observation could reach the surface. Otherwise, it just enveloped in the atmosphere. So by radar observation, the surface of Venus can be reconstructed, and you see that this is the surface of Venus as seen by, of course, radar imaging. There are volcanoes. You can see from here that they seem to be also, they show some effusive activity, probably quite recent, and this is induced by the fact that they are still visible, even if there is such a dense atmosphere with wind activity going on, and is still not so much eroded. So it's thought that the activity is quite recent. You see that the surface of Venus was also studied by a lander. It was Venera 13, launched by the Soviets in 1981. So it could have it gave us the images of the surface of Venus, which is quite an achievement because of the difficulty in going down in such a dense atmosphere. And then the Earth, okay, this is the very well known planet, we know it. Even if I always think that it's really incredible that we have it so close, but still there are a lot of things that are not understood, that we still have to study it. But let's say that with respect to other planets, it's for sure the one which is really well known, very, very much observed, maybe a bit too much from the space. And the particularity of the planet is the presence of liquid water, and you will know what this means from an astrobiological point of view. And of course, is an active planet. The Earth as a moon and the moon. This is the moon, which is again a body which is quite well characterized. Many probes also went to study the surface, but also landed on the surface. And it's very common. I mean, everybody can see the light and dark regions on the moon. Normally, the dark regions are the younger and less craterized, while the light region are the older region of this moon. Okay, let's go to Mars. Mars is the planet maybe. Not maybe. It's the most visited planet by spacecraft. The characteristics are, you see here, it's evident the red color of Mars. Actually, you can see the reddish color also from ground by naked eye. It's like a cold desert. It has a very tenuous atmosphere. And this is the reason why it's not so easy to be there for some. I mean, the temperature excursion, it's very, very high. It's very large, because of course, not having the atmosphere, you will not have the planet doesn't have the capacity to maintain the heat that it's gaining during the day. There is some dichotomy between the northern hemisphere, which is quite flat and low, and the southern hemisphere, which is rough and quite high. It's supposed this difference by, in the past, the presence of an ancient sea. You know that on Mars there are a lot of geological structure that induced to think that there was water in the past, liquid water in the past. And in fact, it's also, I mean, even if it's still a bit debated, some liquid water superficial should be still present today. This white area that you see here, it's ice, but this is made of CO2. And a particularity is that it has a very high volcano. It's the Olympus volcano, which is high about 22 kilometers. I like to show this image here. Maybe Hervé can recognize it. This is a selfie of Rosetta made with Mars in background. So while Rosetta was on the way to study the comet, Mars it took an image of the spacecraft with Mars in the background. Mars, as I said, has been and is still studied a lot also from ground. Different rovers landed on the surface. And you see here, this is the same image, but I had to cut it in two pieces. You see this structure here. It's this structure here. And it's showing you this huge crater. You see here there are some evidence of the wind effects. And as I said, these rovers are going up and down on the Martian surface to study all the characteristics, superficial characteristic of the planet, but they also are collecting samples. They are collecting samples especially in some area which are considered interesting from an astrobiological point of view. In fact, they are collecting samples in some areas where some geological formation witnessing the presence of the water in the past, with the aim of finding maybe some ancient biological form. And these samples are now collected by the rover, but they will be okay, this is another other two images of the surface, but this is what I was referring to. They are collecting these samples and put them in some containers, and in the future, who knows when, because now American space program have been a bit delayed, let's say, so to be diplomatic. And in any case, the idea is to go with a Mars sample return mission that will land on the surface. It will collect all these containers that the rovers already collected, and then it will bring back to Earth the material. So this will be really a big achievement, because also from an astrobiological point of view, because having the sample in the laboratory, it's really something different. I will show it also with the Stardust return sample from a comet. Of course, having remote sensing observations, or even in situ observation, it's very different with respect to when you have the material in the lab. You can really go inside in details of what you are observing and searching for. So let's wait. Here, again, I don't think that you can read all this, but it's just at glance. You can understand how much this planet was attacked, I would say, from space missions. You see that all these are spacecraft that went to visit Mars, so it's for sure the planet that was observed and characterized the most with respect to the others. And then there are small ones. The small ones are, as said, minor bodies. They are asteroids, they are comets, and even if they are small, they are very, very interesting, because it's because they are small. They didn't evolve. They didn't have an activity as, for instance, the Earth, or for instance, volcanism or some energy inside that would mean changing in time. In this case, they are small, so they just remain as they form. More, in particular, more the comets with respect to asteroids. This is debated, but this is what I think, at least. That and I show you two here as an example, two of the asteroids of the main belt, of the asteroid belt, that have been observed by space mission. Here is Gaspra, which is an asteroid that was observed by the Galileo NASA mission. And here you see Eros, that was observed by the NEAR NASA mission. So you see the dimension, it's they are quite small. Here, for all the bodies, I put a table just to have a reference of size and main physical characteristics. And you see that these are really very quite small bodies. Then you have small but not so small bodies, which are, for instance, Cerere and Vesta. These have been observed by Dawn, the NASA mission, in 2011-2015. And these are big enough to be called protoplanets and not minor, let's say, not asteroids. These have been observed because especially Cerere, it's supposed to be, it could also Cerere have some liquid water underneath, but it's still debated. But in any case, it's interesting to have planets of such small dimension because, again, they put some information in the frame of the planetary formation and solar system formation. And then we arrived to minor bodies, to asteroids that were visited by spacecraft, but more than visited. In fact, they've been stolen by some of their material because, for instance, here you see the Hayabusa 2 JAXA sample return mission that arrived. It was just a touch and go, so it was not a landing and a restart. It was just a touch and go on the surface. You see this apparatus here. It's the apparatus that it's collecting the dust. Actually, when it arrived on the surface, it's blowing some air, and then this make the dust flying up, being mixed up, and then it collect these particles, and then it puts the arm back again to bring it back to Earth. These samples from the asteroid Ryugu were collected and brought back to Earth, and now they are analyzed in the laboratories. As Hayabusa 2, also OSIRIS-REx may perform a touch and go. Let me see if I can, yeah. The mission, the spacecraft, first of all studied all the surface as it was, just to choose the place where to, not to land, but where to collect the sample. You see the spacecraft which is arriving. This is a real image. The previous one, of course, it was a reconstruction. And you see again, it's with this air spread on the surface, it makes it go up and be collected by the probe. Here I have another video which is showing the wall surface that was really studied in depth. You will see also, maybe there is not the, okay, never mind. There was also the voice explaining it, but this is the spacecraft. You see this big leg. It's the one that it's arriving on the surface, and this is the apparatus that will, you see, the air coming out and then collecting the dust that it's mixed up by the air. You see the shape of the asteroid and the fact that it's kind of an accumulation of material. it's telling you that probably it's really primordial, and in fact this was chosen by NASA just to go and try to collect a material which remain in the status of when the planetary nebula form the planetary bodies. And the surface is very rough, and you have some specific formation which are kind of different from the other. All of them, they've been studied, they've been characterized in composition, and for instance, magnetite, pyroxene, and this type of mineral were detected on the surface. This is the magnetite. You see the type of mineral that it's the main component of this structure that you see here. And then, of course, it was really well mapped, the surface, because these will be complementary information with respect to the composition that will be it's being determined by laboratory analysis on ground, because it brought successfully back the samples, and now they've been analyzed in laboratory. Okay, maybe we can go on here. Yeah. Yes. I just wanted to show you. Okay, that's enough, I think. Okay, so we arrived to Mars, asteroid belt, and after the asteroid belt, there is Jupiter. And in fact, it's not a case, I mean, it's not by chance that you have this asteroids belt in between Jupiter and Mars. And the presence of Jupiter, such a giant, you know that the gravity field depends on the mass of the body. So such a big giant could have disturbed somehow the formation of a planet at the distance of the asteroid belt. So the asteroids seem to be like the remnants of something that couldn't form as the other planet. Jupiter is really a giant. It has a very thick atmosphere. Even the very light atoms like hydrogen remain trapped in its gravity field because it's very strong. And you see all these bands, they are formed by the atmospheric circulation, so winds rotating in different direction. Then you have the typical red spot of Jupiter, which is actually a vortex of the atmosphere. And what it's inside or underneath this very thick atmosphere, it's still not known. You see the volume, it's so big, it's 1,000 times the Earth's volume, and the mass corresponds to 2.5 times the sum of the masses of all other planets together. So it's really a giant. Isn't in fact called like a small planetary system. Of course, the main difference is that Jupiter is not a star, but it's a planet. But with respect to dimension and to its dimensions and to the fact that it has moons orbiting around it, many moons and quite big ones, I'll show you. It's really peculiar with respect to the other planets. And Jupiter was visited by Cassini-Huygens ESA-NASA mission, and it was quite well characterized, even if the Cassini-NASA ESA mission had the main target as Saturn, its rings and its moons. Here are the Jupiter Galilean moons, so are the 4 biggest ones. They are very interesting, and especially you see they have some peculiarity. Io is the most geological active one, and it's the most active in general in the solar system. It has 400 active volcanoes. And then you have Ganymede, which is the largest moon in the solar system. You see that it's bigger than Mercury. So you can have an idea of why they are calling Jupiter like the Jupiter system like a mini planetary system. Then you have Callisto, which is very heavily craterized satellite moon. Of course, when you have a lot of crater on a surface, this tells you that the surface is very old, because the impact of minor bodies occurred, but they remain there without any transformation due to possible activity of the body or aeolian wind effects, erosions. And then you have Europa. Europa, it's really a very interesting body from what concerns astrobiology. And this is because you see here you have this white surface, and this is because it's covered by ice. And then you have this and then you have these brownish things here that it's coming out from these fractures, and this is organic material. So from an astrobiological point of view, it's very important to go and see what is present on this satellite. And in fact, the main reason why is that from calculation and from the gravity field of Jupiter and the tidal effect that is induced on Europe, it seems that since it's when it's orbiting around Jupiter, it has some tidal effect due to an unhomogeneous homogeneity of the gravity field, the influence of the gravity field of Jupiter on the planet. It seems that Europe is doing kind of this oscillation. But this oscillation, you know that when there is movement, there is kinetic energies. The kinetic energy means there is a source of energy which can be transformed in heat, which is still energy. And heat means that temperature can go up and maybe liquefy the crust of Europe that is made of ice. And so it is hypothesized that underneath the ice crust of Europe there is actually an ocean. For this reason, different spacecraft have been designed to go and study this moon. There is the the Europa Clipper, which is a NASA mission, which will reach. It's I mean it's a NASA mission, and it's going just to understand something about the subsurface of Europe, because if you have liquid water, maybe you can also have some extremophile forms living there. You have in Antarctica, here in Italy, such a structure. You have a lake with a thick surface of ice, and underneath there is liquid water, and there are biological forms living there. So the idea is to go and study this planet. Also, JUICE, the ESA space mission, which will arrive in 2031, will be study the presence of some liquid ocean underneath the crust. And actually, under study, there are also space missions that foresee some kind of landing on the surface and try to make holes in the crust and go underneath with a probe, just to observe darkly the possible presence of liquid water. Okay, we arrived at not Cassini, but I mean, I mixed up Cassini with Saturn because it was a huge and very successful mission. In fact, the Cassini NASA ESA space mission was really a big success, and I always like to take it as an example that collaboration is winning always. But unfortunately not always is, let's say, possible. But it was really something impressive, how many data and results and important results we could get with the NASA ESA Cassini-Huygens mission, space mission. Actually, I also am quite a fan of this mission, also because I was a student when I graduated, doing my thesis on one of the instruments that was on board the Huygens probe. My thesis was with my thesis I designed and realized a Titan atmosphere simulator, because the probe Huygens that was attached to the main spacecraft went down into the atmosphere of Titan and measured the characteristic of the atmosphere, and then imaged the surface. And I will show you something about it. You see that Saturn has these very, I would say, beautiful rings. These rings are orbiting around Saturn, and here again, it's the gravity field that it's trapping these very tiny, small particles that are made also of ice, that are somehow forced to remain around the planet because of the gravity field. And how it's fed, you see that some area are like whipped up, the snow, dust in between in this area. And this is because you have some of the orbit which are not favorable with respect to the gravity field, so they just are void with respect to other areas. And the rings are probably fed by the material which is ejected by the moons of Saturn, and specifically by Enceladus, which is one of the moon of Saturn. And I will show you a picture that testify the presence of this ice coming out. This actually, where is it? I'll show you. Yeah, here. You see, this is the Encelado, and again, it's covered by ice. And in the South Pole, here, have been some plumes of water, of H2O. So ice sublimation have been observed, and this is why it's thought that the rings of Saturn are somehow fed by this type of plumes. So let's go back again here, and this is Titan. As I said, it's a very, very interesting body with respect to astrobiology. This is because it's the only known planet in fact having an atmosphere. The atmosphere is rich of CO2 and hydrocarbons. And from theoretical calculation, and in fact, when I was working on my thesis, it was not yet proved, that theory that was done by Jonathan Lunin, now it's a well-known scientist. At that age, he was a PhD student, and he foresaw the presence of an ocean on Titan. So the Cassini mission was designed to detach this probe from the main spacecraft and let it go through the atmosphere till the surface, just to check the presence of this ocean. In fact, when I was doing my thesis, I had to foresee a pressure of 4 bars in case the Huygens would have go under the liquid surface, because we didn't know, but I mean, we had to be ready for it. So the Huygens was released, the Huygens probe was released, and in fact, already from upward, there was this is a radar image, so you see these dark areas. They means that they are more smooth than light areas, and in fact, this is because these are kind of lakes of liquid something. And it was foreseen, and it is in fact present, a cycle, a liquid cycle, not water cycle like on the Earth, but is still present clouds and rain and liquid lakes. And you see here that the probe landed on Titan, not in the liquid part, so it was landed on a solid surface, but it could image the presence of not an ocean, not a sea, but lakes of actually a liquid which is mainly hydrocarbon. So it's not, I mean, swimming there, it would not be so nice, but still it's very interesting for astrobiological point of view. You see here, these seem to be rocks. They actually are blocks of solid volatiles, including hydrocarbons. So it's the land. It's quite, let's say, you can see very much populated of this type of kind of rock. Okay, Encelado, I already told you about. So let's, I think, again here, if you have liquid water at those distance from the sun, it means that you have to have something that it's rising your temperature there. Otherwise, nothing would be liquid. And here again, it's the same effect, tidal effect of the Saturn gravity field, which is while Encelado is orbiting around Saturn, with vary this gravity field, and this means like compressing the moon and giving some energy to rise the temperature and to liquefy the ice. Okay, we arrived to Uranus. Uranus, here I'm showing you the Hubble Space Telescope image. You see that also Uranus has its own rings. It's not that I was confused and I rotate the image. Actually, Uranus is rotated itself. It has the rotation axis at about 90 degree with respect to other planets. And it is an ice giant, but it's still not so much well characterized and studied. And then we have Neptune. Neptune that was visited by Voyager 2. Again, it's a nice giant. It is dark, cold. It has supersonic winds. You can see here some effect of the circulation, atmospheric circulation. And it's very far from the sun. It is about 30 times the distance from the Earth and the sun. And is the only planet that you really cannot observe by naked eyes, even if you go in a very nice dark area. And you can imagine how distant it is. You know, I guess the Kepler laws, but even if you don't know them, I mean, you know that you can imagine that if you are very far from the gravity, from the mass that it's creating the gravity field that maintain the planet connected to the system. If it's very far from the sun, then it takes a very long time to make a complete orbit. And you see that Neptune was in 2011 completed its first 165 year of orbit since it was discovered, so in 1846. So the first year, it was just the first birthday, it was just occurred very recently. And then you have the nice Pluto that was somehow discarded by the planetary family because it was found that it was too small to be called a planet. So it's a dwarf planet, and it has it's a binary system. Couldn't call it a moon. It's a binary system. In fact, Caronte and Pluto, they form a tight system, and it represents the class of trans-Neptunian bodies, and they are called also Plutinos. They were visited by New Horizons, the NASA mission that arrived till there, and in fact this is the mission that observed the farthest object in the solar system. which is this one. This is the in 2019. It made New Horizon made a flyby on this object, which is a trans-Neptunian object, and it's orbiting in the. It's belonging to the Kuiper belt, and the flyby was performed on the 1st of January 2019. So this is the really most remote object of the solar system that was visited by a spacecraft. Okay, so we arrived at the edge of the solar system, but I told you before something about volatiles, about rocky planets, the fact that they are so close to the sun that they are characterized by such a temperature that it is difficult to think that they retained the volatile component to form our, for instance, on Earth, the oceans, the atmosphere, and so on. So there are theories that explain the presence of water presently on Earth, but in the past, like on Mars, of water due to objects that were arriving on Earth after its formation. So, I said rocky planets, but maybe something like this occurred also on Mars and Venus, but for sure on Earth we well know that there are oceans, okay, and of liquid water, and this is this theory, which is the late Wiener theory, tells us that maybe some minor bodies delivered the water that it's now present on Earth. So after formation, because of gravitational instability that was still present in the solar system at that time, some minor bodies that were coming from out the frost line that I showed you before, maybe they arrived on the other planet because of gravitational field attraction, and they delivered water on them. Which are the impacting bodies? The impacting bodies, as I said, it's something they are coming from outside. I already showed you Osiris-Rex as an asteroid that is considered like primordial, and I'm showing you the comet Churyumov-Gerasimenko that was observed by Rosetta space mission, the ESA mission, and I will talk you about it later. And these are quite small bodies. In fact, for instance, the comet Churyumov-Gerasimenko was the maximum size was about, of course, we cannot speak about radius. You see the shape, it's very regular. But the maximum extension was about 5 kilometers. So quite small to resist to gravitational fields produced by bigger bodies. So these are bodies that may have been contributing to the presence of water on the rocky planets, at least on Earth. These minor bodies, they contain water, but also they contain organic molecules, and these is being observed I mean, I did it with WILT-2 samples returned by the Stardust mission, but also in these samples that are under study in laboratories. It's now stated and sure that these bodies are rich in organic molecules, and I mean, I wouldn't expect something different, because the universe is, I mean, the elements that are really, really very abundant in the universe are more or less this. So they are rich of it. So impacting the Earth, they could have brought not only water but also this type of molecules. So, speaking about life, of course there is not a unique definition of life, but at least we can find something, some common properties that biological form on Earth have. For instance, there is growth and reproduction processes, and then there is evolution and adaptation to the environment, and there is for sure the need of liquid water. And then the need of energy. Without energy, we would die. We or any biological form, even smaller than us. Maybe the smaller, the extremophile, they need much less energy than us. Maybe we will be the first ones to go, because we are too delicate human being. But more or less, for biological form, you will need this type of characteristics. And this is the reason. I mean, if you see the amount of water that we have in our bodies, a bit depending on the age, but still it's a lot. And the water we saw in the solar system, it's quite diffused. We thought many years ago that it was present just on Earth, but we just saw that it's present also in other solar system bodies. Why it's difficult to have liquid water? I mean, it's just enough looking at this diagram. You need some temperature, some pressure, otherwise you would not get it. But we saw that not only on Earth, but at least in the ocean worlds, you still have some liquid water. So there is some hope. We always like to imagine that we are not the only ones. Not as human beings, please don't. I'm not saying that Martians are present in the solar system, but still we think that some biological extremophile form can be present. Dealing with small bodies, this is the family of small bodies that have been visited by the spacecraft. And here you see the very small one here. This is the comet Churyumov-Gerasimenko, and I will speak about the Rosetta space mission that visited and very well characterized this body. And I would say that this is the most efficiently and best characterized minor bodies now in the solar system. And then I will speak also about this comet here, which is 81P WILT-2 comet. That was the comet that was visited by the Stardust NASA spacecraft that collect dust around this, the nucleus of this comet, and brought it back to Earth to be analyzed in laboratories.